Hello students, let us continue the session on mensuration. In previous session, we have discussed exercise 10.1. We shall take up the questions of exercise 10.2. The first question here is to find the areas of the following figures by counting the number of squares. I have taken from A to E. Look at the first one here. How many squares are filled by this particular figure? You count the number of squares, you will come to know 1, 2, 3, 4, 5, 6, 7, 8, 9 squares are filled. So for the first one, the figure contains 9 fully filled squares, hence area will be equal to 9 square units. Look at the second one. Here you count, there will be 1, 2, 3, 4, 5 fully covered squares. Therefore, area for the second one is 5 square units. Observe the third one. Here, if you observe it properly, you will come to know there are only 2 fully covered, fully filled squares, and there are, let me mark in the Roman, first, second, third, fourth. There are 4 half filled squares. Here there are 2 fully filled squares plus there are 4 half filled squares. So area will be equal to 4 square units. Look at the fourth one. Here it's very clear. 1, 2, 3, 4, 5, 6, 7, 8. So the area will be equal to 8 square units. In the fifth one also there is no hiccups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 fully filled squares. So the area will be equal to 10 square units. Very easy. In continuation with the question, from F to I have considered it here. Look at the figure F. Here, how many are fully filled? Fully filled, I'll use Roman 1, 2. How many are half filled? 1, 2, 3, 4 are half filled. So the area will be equal to 2 fully filled. So I'll write 2 times 1 plus 4 are there, which is half filled. So total we get it as 4 square units. Look at the figure G. Here 1 fully filled, 2 fully filled, 3 fully filled, 4 fully filled, 1, 2, 3, 4 half filled. So the area will be equal to 4 fully filled plus 4 half filled. We get it as 6 square units. Next one, there is no problem in doing this. They are all completely filled. There are 5 smaller squares which are fully filled, so 5 square units. In the next one also there is no problem. It's easy to count. 1, 2, 3, 4, 5, 6, 7, 8, 9 fully filled. So the area will be equal to 9 square units. In continuation with the previous question, from J to L I have considered it here. Look at the figure J. How many are fully filled? There are 2 fully filled. How many are half filled? 1, 2, 3, 4 are half filled. So the area will be equal to 2 fully filled plus 4 half filled, which is 2 plus 2, 4 square units. Next figure, there are 4 fully filled and 2 half filled, so area will be equal to 4 fully filled plus 2 half filled. We get it as 5 square units. Look at the figure L. Here the figure is not having sides, it is having curves. In such cases, what do we do? Let me consider it in this way. I'll make a table for that. I'll mention covered area, how many numbers, and area estimate in terms of square units. Here fully covered, how many fully filled squares? How many are there which are fully filled here? 1, 2, there are only 2 fully filled. So the area will be 2 square units for that particular fully filled. How many are half filled? Observe it very carefully. How many half filled squares you can find here? There are no half filled squares. Let me consider it this way, more than half filled. How many are there which are having more than half filled? Here is 1, 2, and 3, 4, 5. This is also more than half, 6. There are 6 which are more than half filled. So almost nearer to 1 fully filled, I would consider approximation. So it is 6. So less than half filled, you count them, you will get 6 half filled. Since it is very less, I consider the area to be 0. So what becomes the total area? The total area will be equal to 2 plus 6, 8 square units. Always remember, whenever this type of shape is mentioned, you will not get the exact value. This is only the approximated value. Let's take up the next one. In these two figures, we don't have the sides. Again, we have to follow the same procedure. Let me make a table for that. Let me mention here covered area and the number and the area estimated. In that, I'll make subcategory. The first category is fully filled squares. Next to that, I'll make half filled squares. More than half filled. less than or filled. Let me take up M, change the color. I'll take M. How many squares are fully filled? Count it properly. 1, 2, 3, 4, 5. There are only 5 squares which are fully filled. How many are half filled? Here exactly half filled, you can't find it. How many are more than half filled? There are 9. How many are less than half filled? There are 12. With respect to this 5, the area estimated is 5 square units. With respect to this, there is no area. With respect to this, it considered almost equal to 1. With respect to this, it considered as 0. So the total area will be equal to 5 plus 9. This will be equal to 14 square units. This is for the figure M. Now I have to do the same procedure for figure N. So these things would change. Observe it very carefully. Let me consider the change in color of the ink. This is N. How many squares are fully filled? There are 8. So 8 will be the estimated area. There is nothing half filled. How many are more than half filled? It's 10. This will become 10. How many are less than half filled? 9. So the area is 8 plus 10, 18 square units. We shall take up the next exercise also in this today's session. It's all very simple. The question here is to find the area of the rectangle whose sides are mentioned. You must know that area of a rectangle is given by length multiplied to breadth. So L into B, length is L and B is the breadth. In the first one, the length is given as 3 centimeter and breadth is given as 4 centimeter. Hence, the area will be equal to 3 multiplied to 4, 12 centimeter square. For the second one, the length is given as 12 meter, breadth is given as 21 meter. Therefore, the area will become equal to 12 times 21. This will be 252 meter square. Length is given as 2 kilometer and breadth is given as 3 kilometer. So the area will become 2 times 3, 6 kilometer square. In the fourth, length is given as 2 meter and breadth is given as 70 centimeter. This centimeter I need to convert now, so it becomes 0.7 meter. So the area will be 2 times 0.7, which is 1.4 square meter. Second question. Find the area of the square whose sides are given. You must all know that area of a square is side into side is same as side square. So for the first one, the side given is 10 centimeters, so the area will be 10 square, which is 100 centimeter square. For the second one, area will be 14 square, 196 centimeter square. For the third one, it is 5 meter, so 5 square is 25 centimeters square. Question number 3. The length and breadth of 3 rectangles are given below. You need to find out the largest area and the one with the smallest area. You must know that area of rectangle is length into breadth. We will use that and find the area. For the first one, area is 9 meter into 6 meter, 9 times of 6, 54 meters square. For the second one, area is 17 meter into 3 meter, it becomes 51 meters square. For the third one, area is 4 meter into 14 meter, 4 times 14 is 56 meters square. Therefore, area of rectangle 56 meters square. That is, the third option is the largest area and area of rectangle 51 meters square. That is, option B is the smallest area. Question 4. The area of the rectangular garden 50 meter long is 300 square meter. We need to find width of the garden. You must know that area of rectangle is length multiplied to breadth. Area is given as 300 square meter and they have given the length as 50, so I need to find the width. So width will become equal to 300 upon 50, it becomes 6 meters. So the width of the garden is 6 meters. Question number 5. What is the cost of tiling a rectangular plot of land 500 meter long and 200 meter wide at the rate of rupees 8 per 100 square meter? Here, area of land will be equal to area of the rectangular plot, which is length into breadth. They have mentioned length as 500 and the breadth as 200. We get it as 1 lakh meter square. Therefore, the cost of tiling 1 lakh meter square land or of land will be equal to 8 times of 1 lakh. Get it as this is per 100 square meter, so divided by 100, so 2 of the zeros get cancelled, becomes rupees 800, so 8000. Here 3 zeros are there. Okay, 1000 into 8 is 8000. So rupees 8000 is the cost of tiling. Question 6. A tabletop measures 2 meter by 1 meter 50 centimeter. What is the area in terms of square meter? Here the length given is 2 meter and the breadth will be 1 meter 50 centimeter, nothing but 1.5 meter. So the area is 2 times of 1.5, which is equal to 3 square meters. Question number 7. A room is 4 meter long and 3 meter 50 centimeter wide. How many square meters of carpet needed to cover the floor of the room. Here the length is 4 meters and the breadth is 3 meter 50 centimeter, nothing but 3.5 meters. So area is 4 times 3.5, yes, 14 square meters. Question 8. A floor is 5 meter long, 4 meter wide. A square carpet of side 3 meter is laid on the floor. Find the area of the floor which is not carpeted. Here the area of the floor is in the shape of a rectangle. So L times B, length times breadth, 5 fours are 20 meters square. Area of the carpet, which is square shape, so square carpet is equal to 3 times 3 side square, 9 meters square. Therefore, area of the floor that is not carpeted is equal to 20 minus 9, 11 meters square. Question number 9. 5 squares flower beds, each of side 1 meter, are dug on a piece of land 5 meter long, 4 meter wide. What is the area of the remaining part of land? Here, area of flower square bed is equal to side into side, which is 1 into 1 meter square. Here, the area of 5 flower square beds will be equal to 1 time of 5, so 5 meters square. What's the area of the land? Here the area of land is 5 times 4, which is 20 meters square. Now we can find the remaining part of the land. So remaining part of land will be equal to area of land minus area of 5 square beds. This will be equal to 20 minus 5 is 15 meters square. So the remaining part of land is 15 meters square. Question number 10. This is very easy, but you need to understand. You need to split the given figure into rectangles to find their areas. The measures should be in centimeters. These numbers, they are given in terms of centimeters. So to split, I'll just draw a line here with respect to this. Then I will draw a line connecting from here to here, this straight line, and one more line from here to here. Alright, if this is 3, this part will become 3 and this part will become 1, so this is 1. This becomes a rectangle. Let me name the rectangle here. It is A, B, let this be C, let this point be D. A, B, C, D is one particular rectangle. Then I will continue the point here, E, F. Let this point where it is connecting, this point be G, and this point be H, H I J, let this be K, this be L. Observe very carefully. For the first one, I am finding the area of H K L M. H K L, let this point be M. H K L M is it's like a square, so 3 times 3, 9 centimeters square. For the second, not second, let me, where is that? For the next part, I'll consider area of IJGH. IJGH. This will be a smaller rectangle. 1 into 2 is 2 square meters. Then I'll take up area of FEDG. FEDG. From ear to ear it's 3, so it becomes a square, so it's 3 times 3, which is 9 centimeters square. Let me take up area of ABCD. Area of ABCD is a rectangle, 2 times 4, which is 8 centimeters square. Therefore, the total area of the figure is 9 added to 2 added to 9 added to 8. It will be 28 centimeters square. Pretty easy. For the next figure, it's very simple. You can just connect this. It forms one rectangle. You connect this, you'll get second rectangle. Here you'll get the third rectangle. If I name this point as A, B, C, D, and let this be E, F, G, H, I, J. What is the area of A, B, C, D? This will be equal to 1 times 3, it is 3 centimeters square. Area of BEFG, from ear to ear it is 3, from here to ear it was 3, so 3 minus 2 will be 1, so 3 times 1 is 3 centimeters square. Area of IJGH is also 3 into 1, this is 3 centimeters square. So the total area will be equal to 3 added to 3 added to 3, 9 centimeters square. Next question is similar to the previous question. You need to split into parts and you have to solve this. I'll be giving you a hint what to do. Here you can connect this. You will get 2 parts here. This part is a rectangle, another part is a rectangle. Easy way. You can solve this and cross check the answer. Probably you'll get 40 centimeters square. For this, if you connect in this fashion, the center part will be a square, and we can easily find the area of all the squares. Here actually there are 5 squares, 5 times of 49, 245 will be the answer. Please check it out. Here what you can do is you can connect it in this way. 2 rectangles are there, and the area you may get it as 9 centimeters square. Please try. Question number 12. This is the last question of this chapter. How many tiles whose length and breadth are 12 centimeter and 5 centimeter respectively will be needed to fit a rectangular region whose length and breadth are respectively 100 centimeter and 144 centimeter? First one I'll take up here. Area of region is 100 centimeter times 144 centimeter would get 144 followed by 20 centimeter square, and the number of tiles will be equal to area of the region divided by area of one tile. We have not found the area of one tile. Area of one tile is the length into breadth 12 into 5. So 14400 divided by 12 into 5. Simplify, you'll simply get 240. So the number of tiles required is 240. For the second one, area of the region, I'll directly find the number of tiles as n, area of the region divided by area of tile. Area of the region is 70 multiplied to 36, and area of the tile is 12 multiplied to 5. 12 3 times, 5 14 times. So 14 3s are 42. So 42 tiles are required. With this, I'll end today's session and this chapter completes. That's all for today's session. Thank you.